Le sprinkler techno.
All right, so welcome to the Sprinkler Techno Aftermatch. I'm again with my good friend JP. Hi, JP.
Hey.
Today we're having Mark Shead with us. He's just out of his conference. It was amazing on courageous delivery, software delivery, sorry. So welcome to the podcast, Mark.
Thanks for having me.
So again, forgot to mention it before in the pre-recording, but it's very casual, so you don't have to worry about anything. We're not trying to corner people. There's no tricky question or anything. It's just well, it's a bit early, but we're faking. We're having a beer together and just enjoying ourselves and discussing topics we love. Sounds good?
Sounds good.
Excellent. So, let's start with the type of deployment risk. You've been talking about, change in the application, changes in the environment. I really like that you put the emphasis on, because, these days DevOps is very the hype word. We want to build this sausage machine that will produce stuff very fast, but we tend to forget that. But before that, we need to put stuff in order if we want quality to get into this packaging solution and deploying automation and see something of value at the other end. So when you were discussing TDD, BDD, and small batches, small changes, I thought it was very good. Would you care to come back a bit on those topics and exchange a bit with us?
So I think one thing kind of, and I had slides on this, but I couldn't fit them all in, so I had to skip them. But I think the big shift with software is that we need to stop thinking so much about building the software and more of we're building a factory that can produce software. Like if you go and the slide I took out was actually had a quiz asking people who invented the automobile. And usually people say Henry Ford invented the automobile. Well, he did not invent the automobile. As a matter of fact, every other person on the list that you could choose from has a stronger claim for having invented the automobile other than Henry Ford. But what Henry Ford did is he made it reproducible. He made it to where you could consistently create automobiles. He made the thing that makes the automobile. And that's what we see as really being valuable. And that's the shift that I think is going to have to happen for us as the human race to get good at software is stop just thinking about how do we write code and start thinking about how do we actually create a factory for creating code and everything that needs to happen to get that value through. And that includes things like TDD is a very good piece of that factory. Behavior-driven development is a very important piece of that factory. Getting change management brought to the front of the process and getting security brought to the front of the process and making sure we're working with users to know what they really need in a way that's optimized for the return on investment they need. And that's happening first instead of after we build it, we figure out if it's useful or not. But those are all of the things that need to happen. And they all are pieces of this factory of actually delivering something.
You have a lot of good points in there. Shifting left is one of them, but I'd like to talk a bit more about TDD first. What do you think it's, I have my notes on the side, so if I look this way, that's why. It seems that in IT, we're not very disciplined, and having disciplines are tough. Like TDD, it's been around for the term was coined around 2001-ish by Kent Beck, but test first approach was there for many years before that. Why do you think that there's so few acceptance and buy-in? Why are there so many resistance surrounding TDD? It seems that every other day we have this article coming up on Medium or on the internet about TDD is dead or something. Why is that? Do you have an opinion on that?
Well, I think part of it is how long have we known it's good for us to exercise? Right? How many of us actually get up and exercise every single day? That's the people that say they value exercise is a much larger set than people that actually are willing to act on it. So I think that's part of it. TDD is hard. It's a discipline that takes a lot of effort. And the other thing I see is when I work with teams, one of the things, development teams, one of the things I usually do with them is we sit down and we do a TDD exercise. Pair up with people and we actually go through and write some code with it. Usually the example I use is if you give me let's see, it would be a Indo-Arabic number. So like what we're used to 1, 2, 3, 4, 5, base 10 number. Give me a number or make a method that takes one of those numbers and converts it into a Roman numeral. So it's reasonably simple. It's something we can understand pretty quickly, but there's some interesting edge cases with it. And my experience has been, I remember the first time I tried to do this, I was on a long plane flight. I was like, okay, I'm a coach. I need to sit down and just do some TDD just to get the experience so I can speak about this better. And this seemed like a good thing to start with. And it was amazing because I know the algorithm I ended up at the end was like, wow, this is a beautiful piece of code. It's very succinct. It's easy to understand. I can look at it and understand there's not edge cases that are going to be missed in addition to all the tests being there. And it was a very, I would almost, so my background is actually music composition. I've got an undergrad and master's degree in music composition. And so for me, looking at that code was just like when I had written a beautiful melody or done something with a symphony or something. I mean, it was that type of experience. And what was amazing is I would have never have written the code that way had I done it just going in and trying to fiddle with it some other way. So it was very revealing to me but it still required a discipline that was hard to make myself do it, just like any other discipline that's really hard to do. So that's usually the thing I do with teams is I get them to sit down and actually go through and do something like that, because usually they end up with things that they probably wouldn't have found on their own. And the other piece is a lot of times teams have heard about TDD and they practice it by writing tests after they've written the code and they think they're doing it. And I'm amazed at how many people that have been in development for a long time have never actually sat down and said, I'm going to write some functionality, but I won't write a line of code unless there's a failing test driving that. So I think part of it is we haven't educated teams well. People don't invest in it because they've never actually done it. They've never been given the space or time or encouragement to go ahead and do code like that.
I have sort of a different opinion on that, is that these practices often come, you were talking about, you sort of made a little off-ramp discussion about SAFe, but it's the same thing, right? Sometimes it comes from the top or from a certain elite group that sort of says we should be doing this. And I've always found that people that are not comfortable doing the testing tend to resist TDD much more than just write your unit test at some point and we'll figure something out. And it's difficult to get a buy-in, as in with SAFe, for example. SAFe, my problem with it is it always comes from middle management and comes down. If you do the same thing with your, we'll call them elites, but that's not what I mean, the elite programmers, to come down and say, if we did TDD, we'd do better. And you have this guy that's been doing code for like 10 years, has never actually lived through it, will often get this weird pushback to it to say, no, this is not the way I do it. You were saying about this is not the way we do it, but there's also a lot of, that's not the way I do it.
Right.
And you try to and it's very difficult to get people to get them to even write unit tests in certain companies. But when they start writing it, then they start figuring it out. But it's difficult to do that from the start. I found.
I think it has to do with mastery,
Yeah, exactly.
There's this weird thing about automated tests, especially unit tests, because we do them more often and more of them. People are ashamed to say, I'm not good at doing JUnit, or I'm not good at writing good tests. Like, it's a discipline. It's something you need to learn. It's something you need to master. If you ask me, do you speak Polish? I'm not afraid to say I don't, because I don't speak Polish, but for some reason, and maybe it has to do with craftsmanship and being responsible, your fear of being judged because you're not good at doing tests and you should be doing it. Maybe it has to do a bit with that.
Well, and I think that's very true. And so 2 points. One, on the idea of it coming from top down for TBD. When I'm working with teams, I'm usually coming in and I'm saying, I want to develop with your team. I want, give me access to your repository, and I want to pair program with your teams, not because I know the program more better, not because I'm a better Java developer than them or a better this than them or that, but I do have experiences, though, and together I'm going to learn a lot from this, just like they're going to learn a lot from it. And together we'll actually both be a lot better. And so that's how I like to introduce TDD. Get together with the, pair people up. Let's get some experience with it. And then let's sit and work together and just see where it makes sense for us, see how it benefits us, and go from there. Because if I'm working with a team and they're saying this, using TDD in this particular place, I think is a terrible idea, I'm probably better off focusing on this place where they think it is useful than trying to fight them on the place where they don't want to use it. But that's just hands-on working with them. But very similar, though, the resistance, pair programming is another thing I see huge amounts of resistance to. And it's because you've got to be vulnerable. And I know as a coach coming in, if I'm going to pair program with someone, I usually try to start off by being the person driving. And the reason is I want to make sure they know that I can't spell anything when somebody's looking over my shoulder, and I can't remember what this particular Java method is called, and I have to go look it up. And I'm going to do some really silly loop here thing that, I did it wrong. And if you're working with someone and you see them do those things, and, I'd like to say, so I fake it and mess things up on purpose just to make, but no, that's not it. I just mess things up because I'm human. Yeah. But if you go through that with someone and you see them struggle with it, and it's like, okay, this is hard. It's okay for me to show that I'm having trouble figuring out what to call this variable or what this is or that is, because I've just sat there with them and seen them have trouble with it too. And we're on the same playing field here. We're going to learn from each other as we go through this. Yeah, but I think the same thing with TDD, of actually having those experiences of sitting down and doing things together like that.
Yeah, I do just the same. I mean, I love pair programming. I love mob programming. I think it's very, it's much easier for people to mimic the way you work if they see you at work, and it's a two-way. It's a two-way learning. You learn as much as you give. So it's an exchange of tips. Sometimes it's a shortcut. Sometimes it's an approach. Sometimes there's always opportunities to learn in pair programming. So I think why pair programming is not used as much, though, it's because there's constraints coming from management that's saying, I'm paying twice for that. And you have people that say, I'm a bit afraid to being judged on how I do things. So there are many different angles like that prevent us from doing it. But as soon as you start it and you try it, it's such a pleasure and such a huge learning opportunity.
Very much.
All right. BDD. That's another technique. Oh, you wanted to go?
No. Right. Go.
Okay, so BDD is another one, and I think it's very complementary to TDD. We were discussing off record just before we started this that you can do when you have a test first approach. You can write first your test from an acceptance point of view in a BDD fashion. And then to make this one pass, you come into an inner cycle of TDD, implementing the functionality and moving upward back to this cycle of TDD at the acceptance level. I think this way of working is not known enough, is not publicized enough. You said you are accustomed to that. Have you applied it in some projects or in your coaching?
Yes. So one team I worked with, this was for the U.S. Treasury, and they were doing a rewrite, and management that was paying for the rewrite was had a very long view that the cost of this application was not in building it. The cost of the application was in maintaining it for the next 10, 15 years. And the cost of the application was in, do we have the ability to change it as new laws come out and different things happen and we need to modify? And that's what they were seeing, was they were investing in keeping those costs low. So they were willing to invest lots of money in making sure that it was done well up front, because that was very insignificant to what they're going to have to pay for it for the rest of its life. And one of the big things we did with that was BDD. And so the application that we were replacing, to do a full test, manual test of it, it took 12 people, 6 weeks. Hang on, let me turn off I've got something else coming on here. I'll be right back. Sorry, I had left the conference up and some people were chatting. So
no problem.
Anyway, so they were doing BDD for this. Well, the previous system, which was only deployed every 6 months. And whenever they did deploy things, it was often to catastrophic results, like really, really bad things happened. But their full test for that was it took 12 people 6 weeks to do a full regression test of everything. So the new system we were building, which encompassed a lot of the rules of the old system, all the rules of the old system, had everything was done with BDD. So if we were creating a feature, when the developer got ready to work on that feature, we would bring in the developer, a tester, and somebody from the user, the person that was actually going to use it. And we'd talk through and say, what does it mean? Let's talk through examples of what exactly this would look like for this feature to be done. They'd go through those examples, and then immediately as when they're done with that, the developer would take it, make them executable, and start writing the code to make those pass. But we got to a point where that thing that took 12 people 6 weeks, we were doing much more thorough testing than that was doing in 20 minutes. So every single change we made, 20 minutes later, we had better feedback than what we were getting previously with those six weeks of 12 people testing it. That's huge. The amount of things that we were able to catch just in 20 minutes was, and developers could run just the things around their particular piece in just minutes. But that's when you checked it into CI/CD, 20 minutes later, you got feedback of, hey, there's this one area you broke over here, or this has some unexpected side effect that you wanted. The value of that is huge. I mean, not just in the value of what we were paying for testing, but just the ability to move forward and know that you hadn't broken something. Because that 6 weeks of testing, they come back and say, here's all the things that are broken. You have no idea what you actually changed that broke those things. You know, you got to dig through all this stuff, and it's scary. And then you don't know if you broke something else. I used to work for a roofing company when I was in high school, and there was one place that we'd work on. They'd hire us to come patch things on the roof. Every time you'd go up to patch one place, wherever you'd step, you'd create 5 more leaks. And so it was this continual process of you fix one thing, break 5, fix one thing, break 5. And that's what testing without having automated tests around it is like. You know, I find something that's wrong. Now I'm going to create more bugs and trying to fix that. And you can get into a place where you're never able to deploy because you just keep making things worse and worse.
Yeah, well, when you don't have automation, the fear of refactoring lurks everywhere because you're afraid to insert regressions. And I think what you just described, it's very interesting because it reaches a bit towards a question you got at the end of your Q&A session, where the person was asking about UATs. Mm-hmm. When you're doing it that way with BDD up front and setting together with those UAT people, the criteria of success for stories, and they are met and backed with automated requirements, it makes a huge difference because it builds trust. Mm-hmm. Since it's automated trust with the business side, when you have a business side, it's also helping, you know, this huge testing, non-regression testing session at the end of your project to melt to very few manual tests. And if you're saying that you reduce this portion and it's more automated, then fewer error-prone manual tests will be processed. So that I think this shifting left is essential. And you mentioned in your conference that this has to, of course, happen for you for testing, but also for security, for all other aspects, to be able to shift all those left at the beginning of the project, take care of matters while we are, you know, the body is open, the code is open, things are not done, so we can produce real value through that CI/CD eventually and rapid deployment.
Go ahead.
Did you get any like resistance or whatever at bringing in those automatic tests? Because at some point it takes time off the programmer's hands, right? That people perceive as the system is being built. I'm not going to get into the argument on whether that's a proper perception, but did you get any, or how do you move around that?
So the system that I'm thinking of had the advantage of the system we were replacing. Like I said, every time they deployed something, even after the testing, there were usually catastrophic results. Like bad things would happen to the database. I mean, just and really bad things on the system that like this is. It had a lot to do with how the economy works, right? You know, so you can not just crash your system, you can crash the U.S. economy if you get this thing bad enough. So like it really, really mattered. So I think it was easier to justify because the experience had been so bad and so dangerous already that pointing and saying, here's a way we can keep that from happening was easy to invest in. Now, one place that we did get a lot of resistance that was interesting is the testers that we had involved, because they were like, there's no way I can test that these tests are actually going to test the application. So we said, that's okay. Come to the beginning of it and help us figure out what you would look for, because those are things we want to make sure we're considering before we go into it. So let's bring your value all the way to the front of it. But then you go ahead and test just the way that you normally would at the end. Now, you'll know what automated tests are running, but we want you to especially look, is there anything we forgot to test that you find? Or is there anything that maybe the test passed just fine, but there's a human element to it that you'll recognize that we're not going to catch in the BDD test. There's an example from what was it, Hawaii, that sent out a text message to everybody.
Yeah.
You're going to die because there's been a nuclear launch. If I understand right, the actual problem that happened there is there were two buttons like right next to one. And one is send the test message, and one was tell everybody they're going to die. And they're same color or whatever it was. And it was really easy to click on the wrong one. And it finally happened. You're not going to catch that type of thing with BDD. But that's what a UAT tester looking at it, or somebody that's saying, how would the user see this? Coming and saying, hey, this looks like there's some risk here. It's not that the risk that the software won't do what it's supposed to. This is just a risk in the human element. So we were asking him to look for those types of things. And what these testers did is they started keeping a list of any time anything slipped through, and then bringing that back to our retrospective and bringing it back to the developers and saying, or when we were starting on a new story, they'd say, here's the type of thing we've missed with these type of stories in the past. So let's make sure we actually have an example that shows how this would work. Well, after doing that for 2 or 3 years, they got really good at it. You know, all that perspective was represented at the very beginning, shifted all the way to the left, and it made a huge difference. And one of the testers that I'm still in contact on this particular project, I still work with sometimes even today, he was saying, you know, I really wasn't a believer in this, but now I'm the biggest convert. This is how you write good software. And I want to work with teams at the very beginning and help them get that process good. Because if I get the factory line working well and the process is good, we will produce good software. And so it's taking their skills and bringing it up a level to the way we produce stuff, rather than just finding bugs of things that we should have thought of before we started on it.
Well, it makes you feel your problems, your constraints more often. It puts them right in your face, and you don't have other options than, you know, develop the skills to master them and be more efficient at it.
Right.
And it's a good segue, I think, to rapid deployment. The more you do things, the better you get at, right? So before we talk about specifically rapid deployment, I would like just to bring something you brought up in your conference. I thought it was amazing because it resonated with us. We had a discussion 2 days ago with another person that was talking also, that was presenting also at the Agile Tour, and it was about technical debt. And we were discussing ways to repay it, to also put it up front and make it visible. And it seems that, it was like that for rapid deployment as well. Your argument was that sometimes it's not easy to estimate the impact of something and to give promise to people that are, you know, you're going to save a ton of money. The much easier way is to go into empiricism and say, well, look at this. We have this situation right now. What's the cost of not doing rapid deployment? Like it was for us in our discussion, what's the cost of not paying that technical debt? Right now, it's 1.5 times the effort, or twice as hard to implement stuff. So it seems to be the way to go to have the buy-in when you want to invest time and effort to implement something.
Right. And one thing with technical debt that I've found is if you are willing, if you have the ability to prove that the application does what it's supposed to from the user standpoint, you now are in an entirely different place of being able to actually change things and deal with technical debt. If I've got an old version, let's say I need to upgrade some framework I'm using, I need to upgrade to a new version of it, and I can make that upgrade and then prove the entire application does what it's supposed to, I'm going to be in a much better place to keep that framework updated as I go than if it requires, 6 weeks of having people manually test it. I was working on one group, and we had invested really heavily in BDD, and after we had gotten in about 6 months worth of development, we discovered that the way that we had structured the entire project made perfect sense at the time, but it was a really bad idea, like the way we had broken up the different modules and stuff. So we talked about it. We're like, well, man, I wish we had have done it this way. Without BDD, that's all we would have been at. I mean, without good testing, it would have been, I wish I have done it this way. There's nothing we can do. We can't justify the risk that we'd involve of going through and trying to change this would be way too high. But we had BDD and we had TDD in place. So I told everyone one night, check everything in. Here's the changes we want to do. I'm playing around with some new refactoring tools that I think might work for this. Check everything in. I'm going to stay up all night and try to change this. And then I'll run the tests. And if they work, then we'll push this out to everybody. So I stayed up till like 2 in the morning, moving everything around and trying it. And we discovered that what we thought was a good way to do it actually didn't work. It broke a bunch of things and it wasn't something we could change to. So I undid my changes next morning. Hey, that doesn't work. Let's think about this some more. Tried a couple other things. A bunch of tests had actually failed when we tried doing it. So we talked about some more. And the next week I was like, okay, I think we've got another plan now. Let's try this. So I went up, stayed up till 2 o'clock in the morning again, did a bunch of refactoring, ran all the tests. They all worked. So we checked it all in. And the next day, everybody said, hey, it worked. Everybody pull this down, spot check it, see if there's any issues you see with this that we don't want to do it. But we've proven all the tests work. And these tests are like 6 weeks worth of tests if we had some people doing it manually. And we just picked up from there and went on. There's no way we would have been able to justify doing that. And this was it was a kind of trivial change. It was just how the application was laid out. But all the stuff we built afterwards that was based on the way the application was laid out would have been worse and worse and worse. And we had the ability to actually change that and put it to what we wished we had have known 6 months previously because we had invested in those tests. And that ability to go ahead and say, hey, I wish this was better. We're going to make a small investment of 8 hours in making this better, and we can prove it works, lets you do things that are just impossible to do and under other circumstances.
Yep, definitely. It's a safety net, right? Where it helps you sleep at night. I'm sure at 2 a.m. when
Yes.
you were done and you saw that, it's breaking. I can roll back. We'll think about it a little bit more. And the day after, when you came back and the tests were passing, but you were confident that you didn't break anything. And
right.
I tend to see that teams sometimes they don't feel comfortable relying on their test suites to make that call for them. So I'm always saying, why is that? And sometimes it's a coverage problem. Sometimes it's they don't feel sure enough about how they do tests. So we try to coach them and to work on that. But it's a tremendously powerful tool to have this validation instantly almost that you didn't break anything.
And I think a lot of times the reason they don't trust it is because it was something that was tacked on at the end, right? It wasn't foundational to how you've created the software. It's seen as, oh, we write the software and then there's testing instead of we have a process for getting features to the user and the foundation of that is good testing. Yeah, and that's a very different system than, oh, we're just going to go bolt some things onto the outside of it.
Yeah, testing and testability was not baked in right at the beginning. Yeah.
Exactly. That's the thing is where you're actually about that. That's the idea. If you're about automating stuff, then everything sort of falls into place. If every question is, how do I automate this? Then everything starts working.
Right. Well, and that comes down to, are you building a factory for producing software?
Yeah.
If that's what you see that you're doing, then those things are very easy to justify. If you're just building a piece of software, it's hard to justify that because you're not trying to build you're not trying to actually build a factory. And I think Tesla is, a good example of this because their stuff has been very much built around how do we automate the it's not a question of whether you can make an electric car. It's a question of, can you build a process for delivering an electric car that's actually efficient? And they see that as everything from the robots in the factory to the way that the car gets dropped off at your house after you order one. It's a bigger piece than just, can we make an electric car?
Exactly.
Well, I think if we want to come back to the theme of your conference, courageous software delivery, shadow deployment and shadow pushing things that are not activated in production, I think it's a good way to to build that trust in our infrastructure and all those things we put together to be able to be more to go faster to the market. And it's, again, in big companies, it's something that I don't see used as much as it used to be. And I'm not talking about IT as software companies that are, as a product, but more in the insurance field or in the financial banking. They struggle a bit to have this shift in their mindset to say that, we could be testing stuff in production instead of testing in our environments. And it goes with your point of when you're not using the real data, you're not testing the right thing, probably, right?
Right. And I think when we say testing in production, that has connotations of you didn't test it anywhere else. And so what I like to get people focused on is, have you actually run this application with real data running through it? Because until you've done that, you don't really know what's going to happen. And can you set up can you do things in a way to where either you're running it live with production data and it is the system of record, but it's a small change, so it's low risk? Or can you run it in parallel, maybe, to where these changes are getting production data, but it's not the system of record yet? And those are ways that you lower risk. And but if we just say testing in production, even though that's what you're doing, it kind of can freak people out.
Yeah, very much so.
Well, and we tend to forget that it's a complementary stuff to all those controls that we've put before reaching production. So it needs to stay in people's mind.
But on the other hand, every time you deploy something to production, you are testing that in production. If it's the first time it's been in production, you are testing it in production. Now, hopefully you've gotten all the risk out, but you're watching to see if anything goes wrong when it goes into production. And part of the question is how much are you testing at one time? Are you testing 6,000 lines of complicated changes that you think will work, but you're not really sure? Or are you testing, we've got 3 lines of changes to code we made, we know exactly what it should do, and if anything goes wrong, we know exactly how to roll it back out?
Yeah. Do you have a big ball of mud, or you're having a small piece to test?
But the thing is, companies are really good at deluding themselves at the size of the changes that they're actually pushing, right? I remember a customer that says, "Oh no, we're just changing 2 things, client management and contract management." You're like, well, that would be your business, right? The actual interactions are in the thousands, but you're saying everybody in management is saying we're just changing 2 things. That's a scary, that's where they sort of don't get the actual risk that they're pushing.
Right.
Very good.
The way we talk about software, I think, kind of encourages us to do that, because we talk about we're going to build software, right? And so it's kind of this idea of we have to get everything out there before any of it's useful. It's not, I can't build people don't build a house and say, okay, I got the bathroom working, I'm going to start using the bathroom and then we'll deal with the foundation and other stuff. But if we think in terms of how a city grows, you don't usually build a city, right? A city grows over time, and you build something here and then you take it out and you make small progress, and it evolves over time. And I think if we think of software as we're trying to evolve this, it pushes us toward being more willing to make very small changes to it that are toward what we want, rather than, okay, now here's version 2, bang, hope it works. We're going to change all the things like you mentioned.
New York City version 2, like that would work.
Right. Yeah, you can. Definitely. I mean, and New York City has subway systems that like they used to use and now they don't. And then they built other subway systems and they tore down this building, put another building up. And it's all just a constant evolution. And they find, I mean, if you run around New York City, there's all those things they put over the sidewalks so things don't fall on your head. You know, the entire thing is set up. The entire city is set up to be in constant change.
Exactly.
And that's accepted and part of the way that they got to where they are.
Yeah,
exactly.
That's enormous. Even if we transpose that to IT and software, it's enormous. The experimenting and learning phases, where you want them to be as short as possible to get retroaction and feedback and adapt and pivot, the MVP approach, basically. Yeah. through your talk, you were talking about, well, not mentioning it quite, I think, but it was always in the background, continuous learning. We need to learn all the time, right? From all we're doing. And I'd like to hear you about leadership and our relationship with failure. There's this quote that I love: "In life, you never fail. You either win or learn." And I think it's very powerful, because a mistake is just a mistake if you haven't learned from it and learn how to not reproduce it in the future. So all those postmortems, that's what they're there for, right? As a company, we want to learn. So in all this rapid deployment and all you talk today, how continuous learning is such a fundamental piece of the puzzle.
So one thing about, your quote was you either succeed or you learn. There are some things. Okay, so take the guy that climbed up the Eiffel Tower and thought he had a suit to fly with. Okay, he did not succeed, and in one way he learned, but his learning was catastrophic, right? It was terminal, right? And so I think now everybody else learned from it. Don't do that thing, you'll die. But if we're thinking of software and how we approach things, we need to make sure that we're setting up the risk that we're taking is risk we're willing to take. I know a guy that decided, I'm trying to think if I should tell this. Yeah, I'll tell anyway. He had decided he had come up with a scheme for winning at blackjack, I think it was, and he had done it and stuff. So instead of getting with some friends and practicing it to see if it works, he goes down to the casino. And he every time is like, okay, I've got, and so he's testing in production in a very poor way. And it ended up having some very bad consequences for him, because the risk he was taking wasn't just a matter of I'm going to learn from this. It was doing things that could have very big impact to him. So when we're thinking about how we want to accept risk and accept failure, we have to make sure that we're biting off chunks that are small enough that we're willing to accept the failure of that and that we can fix it quickly. We're not jumping off the Eiffel Tower saying, hey, we'll either learn from this or we'll succeed. And sometimes we do that with software. We're willing to take, we'll take a big leap and we're going to try this huge thing. And the risk we're taking on isn't something that we're willing to actually deal with. People get fired over. Hopefully you don't die. You're not. Well, I don't know. There was the that airplane, the Air Max plane. The
Air Max, yeah.
They were taking on a risk on that was higher than probably what they should have been taking.
Very much so.
I mean, lots of other problems around their software engineering.
Well, hey, it just started flying again today, so.
Well,
yes, right.
You shouldn't get on a plane crossing your fingers. That's the thing, right?
Yeah, I love your take on this one, because I live by continuous learning. I really enjoy talking about it, promoting it. But sometimes I have people that are a bit pushing on the brakes for that. They're not. They're saying, doing mistakes, for example. You're not allowed to do mistakes in production, and basically. Your argument is that, well, if you do small mistakes all along, you'll be first good at recovering from them. And also, if you do small mistakes, results of those mistakes should be small as well. So the risk, you're mitigating it, basically.
Well, and I think what we forget sometimes is you are taking a risk every time you deploy. You're taking a risk even if you don't deploy to something to production. It can just break. There's all kinds of things that can happen. So the risk is there either way. It's a matter of how big is it. And if we pretend that it's not there, then say, oh, well, this other thing's risky because we're deploying frequently. No, you're not properly looking at the risk of what you have today. It's a lot more risky than you realize. Bad things happen. But what we do is we say, well, we weren't planning on that happening, so it doesn't count. Well, that doesn't. It's like people saying we need waterfall because we've got a firm and fixed date. Like, okay, well, what's going to happen if you're not going to meet that date? Well, we'll change the date. Well, then you're building flexibility into it. You're just pretending it's not there to properly motivate people. And that doesn't, you haven't achieved anything.
True.
Okay.
You want to go with another question?
No, I'm okay. I've pretty much covered everything I wanted to cover. There's some fun answers in there.
And I apologize. I'm going to have to wrap things up here in a minute to jump onto something else. I'm sorry I was late getting here because these are great discussions.
It's all right. Yeah, well, I same here. I really appreciate our discussions. Thanks a lot for your time, Mark. And I think we should maybe wrap it up just to make sure you don't get too late for your other talk. And maybe let's do this again some other time. It was very interesting.
Okay, thank you guys so much. It was great to talk to you.
All
Thank
right.
you.